Hello everyone, welcome to the channel. I am Piyush and today I am going to discuss a question from the contest Starters 28. The question is Permutation Xority. You must have read the question. For a brief explanation of the question, you are given a number n and you have to print one permutation of length n such that the numbers after subtracting the adjacent elements should give you 0 on taking XOR. Now let's jump to the solution part and make sure you watch the video till the end. So let us take an example. When n is equal to 5, let's take a permutation 1 2 3 4 5, the general one, from 1 to n. Now according to the question, subtract the adjacent elements, you will get only 1, and since n is equal to 5, then you will get 4 ones. It is obvious that when you subtract the adjacent elements, you will get n minus 1 elements. So since if you take XOR of n identical things and when n is equal to n is an even number, then you will get 0. So here there are 4 ones and you will take XOR of 4 ones, so you will get 0. And since you will get n minus 1 ones, so when n will be odd, you will get even number of ones. To get more clarity, let's take one more example when n is equal to 7. So the permutation 1 2 3 4 5 6 7 and subtract the adjacent elements, you will get 6 1 this time. And now if you take XOR of all these, you will get 0. So you can observe that whenever n will be odd, you just have to print the sequence from 1 to n. This is one conclusion here. Now let's move on to the other cases. There's one more case that when n is equal to 2, there will be a permutation 1 2 and you will only get 1. So it's obvious that you have to print minus 1 when n is equal to 2. This is the second conclusion. When n is equal to 2, print minus 1. So the only thing remains here is when n will be even. And to be more specific, the only tricky thing here is when n is equal to even, when n is an even number. Okay, so let's see what happens. Let's take an example of n is equal to 6. It is given in the test cases, so let's take it. So what happens when we take the permutation 1 2 3 4 5 6, that is 1 to n, in even cases? So subtract the adjacent elements, you will get 5 1 this time. And if you take XOR of all these ones, you will get 1 as your final result. Now you have to think about the changes that you can do here to make the XOR 0. What I think is the first 2 1 are good for me because they are giving me 0, as 1 XOR 1 will be 0. So this one is okay, you don't have to change anything here. The problem is the last 3, because this one is giving me 1. You may ask that why not the first 4 1? Because the first 4 1 can also give me 0 after taking XOR, but after that you will have only 1 1 left. If I'm not confusing, you will have only 1 1 left, that is the last one. And what changes can you do with only 1 element? No, nothing. That is why I take at least 3, and stick to the video, you will get to know the reason. Now let me tell you a fact, an important one that we are going to use here. The fact is When you take XOR of 1, 2 and 3, you will get 0. You can check it. So we have to make 1, 2, 3 here. We have to arrange 4, 5, 6 in such a way that you get 1, 2, 3 after subtracting the adjacent elements. So how can you do that? You can see 6 minus 4 will give you 2. And for 3, 6 minus 3 or 3 minus 6, the absolute value of 3 minus 6 will give you 3. And for 1, 5 minus 4 will give you 1. This means you have to arrange 4, 5, 6 in such a way that 6 and 4 will be adjacent and 3 and 6 will be adjacent. And also 5 and 4 will be adjacent. Now let's see how can you do that. Okay, so we have 4, 5, 6 here. And we want 6 and 4 to be adjacent. So we will swap 5 and 6. This means you have to swap the last two elements of the permutation. Now 4 minus 6 will give you 2 and 6 minus 5 will give you 1. And the 3 which is at left side of the 4 will give you 1 also. So we have 2 and we have 1. The only thing we want here is 3. So we have to swap elements such that 3 and 6 can become adjacent. So it's pretty obvious that you have to swap 4 and 6. So the elements will be like this: 6, 4, 5. And now 6 minus 4 will give you 2, 4 minus 5 will give you 1, and 3 minus 6 will give you 3. Now I think the problem is solved now. So our final answer for n is equal to 6 will be 1, 2, 3 and 6, 4, 5. After subtracting the adjacent elements, you get 1, 1, 3, 2 and 1. And the first two 1 will give you 0, and 3, 2, 1 will also give you 0, and 0 XOR 0 will give you 0. So this is our answer for n is equal to 6. I hope you get the idea, and if for more clarity I will show you one more example of n is equal to 8. First of all, take the permutation 1, 2, 3, 4, 5, 6, 7, 8. And subtract the adjacent elements. You will get 7, 1, and after taking XOR you will get 1 because n is odd. N minus 1 is odd. And these first 4, 1 is good for me because it will give you 0. And the last 3 is the problem. So you swap the last two elements as we did it before. And after that, you swap the second last and third last. This was the idea. First swap the last two elements, and after that swap the second last and third last. So you will get the 4, 1 after subtracting the adjacent elements, and 3, 2, 1. These 4, 1 will give you 0 after taking XOR, and this 3, 2, 1 will also give you 0. So this is the final permutation for n is equal to 8, and this is our answer. So when n is equal to 2, you have to print -1. When n will be odd, you just have to print 1, 2, n. And when n will be even, you have to print the array after swapping the last two elements, and then swap the second last and third last, and then print the array. I will not show you the code of this because it is very simple. I am attaching a link for the code file, and it is in my Telegram channel. So make sure you also join the channel. And if you want me to make more such videos, you can tell me in the comment section. See you in the next video.